Hi guys, I'm Ankit. In this video, we shall see another problem on LeetCode. Valid palindrome part 2. So given a string, return true if S can be a palindrome after deleting at most one character from it. So the question says, as you know, what do you mean by palindrome? So palindrome string or palindrome number, if we say palindrome number 121, when you read it from left to right and right to left, it should be the same. Left to right 121, right to left 1 to 1, same. Similarly, if we take a string, let's say ABA, then if you from read it from left to right, it's ABA. Again from right to left, ABA. So both are same. Such numbers or strings are called as palindrome strings or numbers. So here in the given question, we have to check if the string can be a palindrome after deleting at most one character from it. So in the given string ABA, do you need to delete any character so that it becomes palindrome? No, ABA is already a palindrome. If you read it from left to right, right to left, it's the same. And the question is at most one character. They have not told after deleting one character. Deleting a character is not necessary. It is not mandatory. It is necessary if you want to do that, only then you delete it. Otherwise, you need not to delete any character. So, but at most one character can be deleted. So, I minimum is 0, max can be one character which you can delete from the string and check whether the given string is palindrome or not. If we take the next example, ABCA, in this, if we delete A, will you get, without deleting any character, it's not possible to get a palindrome because ABCA in the reverse order, it will be ACBA, which is not equal to ABCA. So if you delete A, then BCA can be a palindrome? No, it is not a palindrome. If you delete B, ACA can be a palindrome? Yes, this is a palindrome. So yeah, there is a palindrome existing in this given string after deleting one character. Hence, this is a valid palindrome. You will be returning true. So this is what the question says. So once you find a valid palindrome, you can stop. Just return true in that. You need to find whether the valid palindrome exists in the string or not. So what is the approach to solve the problem? So as the question says, palindrome, as I said. So if a given string is ABA, how do you check whether it's a palindrome or not? One pointer you keep in the beginning, another pointer you keep in the end. Check whether A and this are the elements at the position, characters at the position A, left and right are equal. If they're equal, increment the left pointer, decrement the right pointer. So left and right are pointing to same, that will be equal, so you stop the loop. So other option, another example I can give you ACCA. Left pointer, right pointer, A equal. So left increment, right decrement, left increment. Okay. Again CC are equal. Yes, this is a valid palindrome. But here the twist is we have to check after deleting at most one character also there is if there does not exist a palindrome within the given string, we have to check after deleting any one of the characters we can get the palindrome or not. So what is the normal brute force approach you can apply to this question? The normal brute force approach would be first you check whether the given string is palindrome or not. If this is not the palindrome, so for checking how do we check a given string is palindrome on as the function I say. As I explained, we will have a left pointer, right pointer. Until left lesser than right, check if string of left is equal to string of right. If it is not equal, just return false. If it is equal, just left plus plus here to do, and right will be minus minus. Okay. So this is a palindrome. How do we check a given string is palindrome or not? First, check whether the entire string is palindrome or not. If that is a palindrome, just return to direct. If that is not a case of palindrome, then don't take into consideration the first character from the string. Check for the remaining character, whether it's a palindrome or not. Again, go here. Do not take the second character into the count. Again, check for the remaining character. It gives a palindrome or not, ACA. Then again, check here it gives. If it doesn't, check, don't consider this C. ABA, does it give a palindrome? Yes, even that is a palindrome. Don't consider A. ABC is not a palindrome. So like this, we have to check for each character, removing and not considering it and checking the palindrome or not. But that is not an optimal approach because every character you need to look into that. What if the string is very large? So what other approach we do is, let's take this example ABCB. Okay, ABCB. So we have this example ABCB. So as I said, we have two pointers, one in the beginning, another at the end, and this is left and this is right. Now check whether A is equal to B. The string of left, if it is equal to string of right. Is it equal? A equal to B? No, this is not equal. So if this is not equal, then how do we check whether there exists which character we do not consider? We don't consider either A or B. There is one option, either you can not consider A and check whether the given remaining string is palindrome or not. Other one option would be you don't consider B and check whether the remaining string is palindrome or not. There is one other option left. So how do we check this option? So what do we do is, as in when you find so as in when you find this S of left is not equal to S of right, what we do is recursively we call the palindrome is palindrome function. How do we call it? Check is palindrome of the given string left plus 1, comma right, or is palindrome of given string left comma right minus 1. You check either this is palindrome or this is palindrome. This or this either ABC or BCB. You check why either these two are palindrome or not. So let's give the recursion tree AB, CB. So here we have pointers A and B which are not equal. So two recursive calls you do. Why or condition? If either ABC or BCB, sorry, yes, why are we giving or condition? Because here in this case we have to check either ABC is a palindrome or BCB is a palindrome. If any one of them is true, then there exists a valid palindrome in the string. That is what we need. So what we do, given a string, if two positions, left and right position strings are not equal, then you recursively call one is for ABC, another is for BCB. First this side, left side, because this is first called, then this is called. Here you check recursively. Now again ABC, keep a left and right pointer here. Is A and C are equal? No, A and C are not equal. Again, recursively, you check AB is a palindrome, either AB leaving C or BC leaving A. Again, you have two pointers here. So left and right, they are not equal. So that means this is not a palindrome. You just written false. Here, you need to split. There is because left is lesser than right. These two are not equal. If you split it, it will give you A, B. Uh, So here, yeah, here in this case you stop here only. This will return you false. Again you look for whether BC is a palindrome or not. No, this is not a palindrome. Again this will return false. Now both are returning false. This will be false. Now you go to this condition. Here you have not obtained true. This condition we are not obtained true. This is false. So you go for this condition. Again you check pointer here and one pointer here. B, B are equal. Yes. Increment left and decrement the right. C is equal. So yes, this is a palindrome. You just return true here. So once you get to stop, you need not to do a recursive call again B, C and C, B. This is not required because here you have obtained a valid string, you stop the loop here. This is how recursively we solve the problem. So the basic logic I'll tell again, we have the string A, B, C, B. Okay, have pointer, beginning, end. Check whether they are equal. If they are not equal, then check for the palindrome without A once and without B once. So without A means it will be B, C, B. Without means it will be A, B, C. Here check again if there exists a palindrome. Here they are not equal. Again check. Without A will be BC, without C will be AB. Here also. Without B will be what? BC. Without this B will be, it will be CB. But this won't happen because this is itself a valid palindrome. Here recursively you go till here. This will return true, this will return false, false, false. This will be false. So again you go this condition, this will become true and return answer as true. So this is how we solve the approach. And let's solve this. So left is initialized to 0 and right is in, pointing to end of the string. So while left lesser than right. Equal to is not required. Left lesser than or equal to is not required. If it is BCB, if this is equal, do we need to check whether CC is equal or not? No, not required. If it is of even length also, B, B, you have. Then C, C. Again, no, it will get crossed. So this condition is not required. Left lesser than right is sufficient. Left lesser than equal to right is not required. So Now check if s of left, if it is not equal to s of right. So in the given case ABCA, ABCA, your pointer here. Here it is equal. So increment the left pointer and decrement the right pointer. BC, is it equal or not? No, this is not equal. BC is not equal. In this case, what you do is you check within here. Left plus 1 comma right. So you check whether C is palindrome or B is a palindrome. Here yes, B and C both are a palindrome. So like that. So if S of left is not equal to S of right, what do you have to check? We have to write a palindrome, is palindrome function. Now I'll just, okay, let's write is palindrome function. So boolean is palindrome of string S, comma int left, comma int right. So here also while left lesser than right, if S of left not equal to S of right, what should be done? Just return false. Okay. Otherwise left plus plus right minus minus. So next, if all of them happens, just return true. And okay, one major mistake I had it is we are not calling AB here. This is not happening. Why? If we do this, see already in this year in ABCB, you're not taking B into consideration and ABC are obtaining. Again, if you delete C and if you get A, that means you're deleting two characters here. If they ask after deleting n number of characters, then it was okay. What is the highest use string palindrome string length you can obtain? But that is what not they're asking. At most one character you can delete. So if the given string is ABCB, have a pointer here, have a pointer here. If they're not equal, ABC you can call, BCP you can call. That's it. Not more than this. This is not allowed. So that's why we'll not recursively call here. Check whether this is a palindrome string or not. At most only one character you can delete. If we do this recursive call, that will be like we are deleting more than one character. B is also deleted, again C is deleted. We check only AB into consideration. That we cannot do. That can be done if they ask in the question after at most deleting at least how many minimum number of characters can be deleted such that you get the highest palindrome string. If such question if they ask, then we can solve that. So is palindrome of string comma left plus 1 comma right, or is palindrome of string comma left comma right minus 1. So just give return here left plus plus right minus minus. So return true. Sorry for the confusion here. Yeah, this you will not be calling. As I said, at most one character you can delete, not more than that. If you do this, you will be deleting C. Again, you will not taking you'll be deleting A here. Again, you will not be taking C into consideration. So two characters you are deleting. That it happens. So you cannot do that. So at most one we will do. Check whether that after deleting one character, if it is equal or not. If it is not equal, return false. If it is equal, return true. Either of them should become true. So we shall run this and check. Okay. Second option. Second option is left plus plus right minus minus. Now we will run this. Yeah. And for Java, the same logic applies. So here we do let's not character it of left and right. We can't just or else you have to convert into array of characters and obtain it in a index form. Otherwise, you will use character it function. So we shall submit this. Yes, successfully submitted. If you understood the concept, please do like the video and subscribe to the channel. We'll come up with another video in the next session. Until then, keep learning. Thank you.